code to cloud. There we go. Okay, so we will be solving quadratic equations using the quadratic formula today. Does that sound familiar to everybody? Maybe, maybe not. If you're alive out there. Okay. So whenever you are trying to solve for the x-intercepts of a quadratic function or equation, one of the ways to solve it is by using the quadratic formula. So here's our quadratic equation. Ax squared plus bx plus c equal to 0. And if we want to solve for the x-intercepts, we use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, everything is over 2a. And one way to see that, so you don't make any mistakes, is to break it into two fractions. You can rewrite the quadratic formula as negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. This just shows you that every term in the numerator is over that same denominator of 2a. Students always make the mistake of just putting the square root over 2a and leaving the b out of it. So remember, everything is over 2a. Okay, and down below, if you want to break it down into 4 steps to, that's like 5 steps, to make the process easier, we can go ahead, but I figure it's a lot easier just to do it in one go. Yes, one of the things you want to start off with is labeling what A, B, and C are. And once you know A, B, and C, you can then plug them into the quadratic formula and simplify. And again, if you wanted to do it step by step by step, you would find out what negative b over 2a is. You would find out what b squared minus 4ac is. And then you would take the square root of that, and then eventually lead you here. But why not just do it in one go? If you know what A, B, and C are, let's just go ahead and do it. Okay, so let's go ahead and try these out. Let's see how much I can zoom in here. Zoom, zoom, yeah. Give me all that space. Okay. All right, and I'll use that space over there. Okay, look at number 1. X squared minus 4x minus 3. What is the value of A here?
1.
1. What's the value of B?
Negative 4.
And what's the value of C?
Negative 3.
Negative 3. So once you know A, B, and C, go ahead and plug them into the quadratic formula. So here we go. X equals negative B plus or minus the square root of B squared minus 4 times A times C. All over 2 times A. There you go. If you know A, B, and C, you can just plug everything in. Okay, now we can simplify. So this will become X equals negative times negative 4 becomes positive 4 plus or minus, and then inside your square root, you have negative 4 squared, which becomes 16, and then negative 4 times 1 times negative 3, that becomes positive 12, all over 2. Okay, clean up a little bit more, and this becomes 4 plus or minus the square root of 28 all over 2. All right, now let's have some more fun. Can you break down the square root of 28? Give me 2 numbers that make 28.
4 and 7.
4 and 7. Square root of 4, square root of 7. What is the square root of 4?
2.
2. Can you break down square root of 7 anymore?
Nope.
No. So here we go. We're almost done with our final write-up. So x equals now 4 plus or minus 2 square root 7 all over 2. And now this 4, this 2 can all be reduced by what number?
2.
2. Or if you need to see it, split them into 2 fractions. And we can also rewrite this as 4 over 2 plus or minus 2 square root 7 over 2 and get our final answer of 2 plus or minus square root 7. There we go. All right. Any questions on that? Everybody good with that?
Well, what happens to the 3? The negative 3.
We already used it.
Where?
And right there.
Oh. Duh.
It's just part of the formula. That's it.
So if I type all that in, what the plus or minus, how would you do that on the calculator?
You would just have to do 2 separate calculations. You would have to do 2 plus the square root of 7, and then you would have to do 2 minus the square root of 7. So I guess that's good enough to say. I could show you as well. Like if you were to try to figure out what the square root was on a calculator, I would do the square root first. So I would say square root, and then I would write everything, type everything as I have written it down. -4 squared, and then -4 times 1 times -3. But if your calculator doesn't break it down for you, then you're going to be left with a bunch of nasty decimal numbers. So maybe try it without the square root first and just do the inside first. -4 times 1 times -3, and there's a 28 that we got in our calculation earlier. So you can, like I said, you can follow the above and do it step by step, especially if you're using a calculator. But for these examples, we don't have to break them into decimal number.
Now, when you're using that Desmos calculator, is there a special calculator you use, or
Like
weird
if
stuff?
if I wasn't using Desmos, I would just be using this blue calculator. And this blue calculator actually will give you the square root answer, which is pretty cool.
Well, I mean, when I got into it on my computer, the graphs and stuff had different numbers like -1,000 and all that. I'm like, well,
No, it should be
like,
the same. If not, you can probably just use the scientific calculator because we're not really graphing on these. So I could just, on Desmos, they also have the option of just a plain old scientific calculator. So
trying to find it. I'm like, they're showing me all these graphic calculators. I'm like,
yeah. So what I learned on the phone was that if you're actually just on the browser, if you scroll down on the bottom of your phone, you'll see the different calculators at the bottom. So I don't think it'll show it. Oh yeah, it shows it here. Graphing calculator, scientific, 4-function matrix. So whatever you need.
okay.
Cool. Okay, let's keep rolling. Number 2. How many of these we got? Oh, we got a lot of these. Might want to skip around. All right, but let's do number 2 first. So in order to use a quadratic formula, our quadratic equation must be in the proper form. So remember that proper form is ax squared plus bx plus c equal to 0, meaning the perfect form, 0 needs to be on one side. So if you look at number 2, is this in the perfect form? No. Who needs to come over?
9.
9.
9, right? 9 needs to come over. Okay. So we subtract that 9 over, minus 9, and get left with x squared plus 3 equal to 0. Okay, now label A, B, and C. What's the value of A here?
1.
1. What's the value of B?
0.
0. And what's the value of C?
3.
3. All right, perfect. So now put these in the quadratic formula. X equals negative B plus or minus the square root of B squared minus 4 times A times C. All over 2 times A. Okay, cool. Well, let's clean this up and you'll just be left with 0 plus or minus the square root of 0 minus 12 over 2. Okay, now some more cleanup. If you want to see this clearly, let's go ahead and split it into 2 fractions. You'll have 0 over 2 plus or minus the square root of negative 12 over 2. All right. Well, this 0 over 2 just becomes what?
0.
0. So you get 0 plus or minus square root of negative 12. Now, does anybody know what happens when you square root a negative number? Do you know what the end result is? No, it's okay if you don't. Well,
No.
I guess the big question is, can you square root a negative?
No real numbers, right?
You get no real numbers. What type of numbers do you get if they're not real?
Imaginary?
Imaginary. So if you've never seen imaginary numbers, cool. If you've seen them, but it's been a while, cool. So you will only get imaginary numbers if you take the square root of a negative number. So an imaginary number is known as I, and I is known as the square root of negative 1. So this is what happens when you square root a negative. You get an imaginary number that's known as I. Okay, so whenever you see the square root of a negative number, all you guys are going to do is pull out an I. So I'm going to rewrite this one, square root of negative 12 over 2. I'm going to rewrite that one as I square root 12 over 2. All we have to do is take that imaginary number out. You take the square root of negative 1 out, it becomes an I. Okay, but then we still have a little bit more work to do. Can you break down the square root of 12?
Yes.
Yep.
Give me 2 numbers that make 12.
6 and 2.
Give me 2 other numbers that make 12.
4 and 3.
4 and 3. 6 and 2 work, but whenever you're trying to reduce square roots, try to go for numbers that you can reduce, like 4, that are perfect squares. Because now I get 2 square root 3. Okay, and now we'll get x equals plus or minus, I don't need that 0 there anymore because 0 is 0, and I get 2, let's see how I'm going to put this. I have 2 square root of 3, and I still have that I out front. So the way I'm going to write this is as 2 square root of 3 I over 2. And one last simplification. what two numbers are going to cancel out?
2.
2. Your 2's are gone. And now we are left with
3.
plus or minus. And you can write this two ways. You can say I square root 3 or square root of 3i. I think the first would be preferable, so you don't think that the I is underneath the square root. So I would stick with the first one. There you go. So this is what happens when you try to square root a negative number. You get an imaginary number, which is known as I. All right. That was fun. So everybody good with that? Okay. Cool. All right. Let's do, okay, let's bounce around. We got a couple of these, but we have a lot of notes to cover. Look at all that. So let's just jump around. I'll let you guys pick. 3 or 4.
Do one with fractions.
Do one fractions. Okay, that means we're going straight to number 6. I love it. All right.
I hate it.
Hey, don't worry, it's not bad. We're just plugging numbers in, okay? All right. So number 6, x squared minus 3 halves x minus 1/4. What is the value of a?
1.
1. What is the value of b?
-3/2.
Negative 3/2. And what's the value of c?
-1/4.
Negative 1/4. Okay. We are good to go. Here we go. Plug them in, and we'll have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, we clearly have some work to do, right? All right.
I got
So,
a question.
What's up?
Those parentheses that you put around the -3/2,
Mm-hmm.
the parentheses have to go there?
They need to go there. If you forget parentheses, then it is incorrect. Because remember this, -3 squared and -3 squared in parentheses. This one gives me -9. Guess what this one gives me?
It's not.
+9. So
Okay.
you need parentheses. Okay.
I was just checking because I noticed I had to do a few over because I wasn't coming out right, and I think it was because of the parentheses.
Oh yeah. Okay. So now we have some work cut out for us. So actually, let's move over a bit and let's figure this inside part out. So this part. So -3 halves squared. -3 halves squared. Well, what is 3 squared?
9.
9. What is 2 squared?
4.
4. All right. And then we have -4 times 1 times -1/4. Putting this together, do it step by step. -4 times 1 gives me -4 times -1/4. And now -4 times -1/4. What's going to happen to my 4's? Or they cancel out. Or if you don't see it, rewrite it as -4 times 1/4 just becomes 4/4, which becomes
1.
1. 1. All right, cool. It becomes a positive 1. So what we're left with inside these square root, so 3/2 plus or minus the square root, is you are left with 9/4 plus 1 all over 2. Now, of course, we have to handle that 9/4. So we'll do that out here. 9/4 plus 1, put 1 as a fraction and get a common denominator of what?
4.
4. And you get 9/4 plus 4/4, which gives me 13/4. Okay, cool. We're getting there. So now the next step, you have x equals 3/2 plus or minus the square root of 13/4 all over 2. All right, so we're still dealing with this square root. Oh my goodness. So now the square root of 13/4. The square root of 13/4. Well, can you take the square root of 13? Can you take the square root evenly of 13?
No.
No. What are the only numbers that make up 13? 1 and
1 and 13.
13.
and none of those you can square root, right? So the square root of 13, believe it or not, just remains the square root of 13. What about the square root of 4?
2.
Guess what? You now have the square root of 13 over 2. The 2 is no longer in a square root. Okay, so still moving. You still have 3/2 plus or minus, but now you have square root 13 over 2 all over 2. Oh boy. Okay. So got some options here. We can multiply both terms by the reciprocal of the denominator, or split it into 2 fractions and then multiply each by the reciprocal of the denominator. What do you want to do?
Split it into 2 and then we'll multiply each.
Okay.
I feel like that would be easier.
All right, whichever way you want to go about it. So we will have 3/2 over 2 plus or minus square root of 13 over 2 over 2. So we have just taken it, split it into 2. Now we'll multiply by the reciprocal, because these 2's I can put over 1 and fraction over fraction, multiply by the reciprocal. That becomes 3/2 times 1/2 plus or minus square root 13 over 2 times 1/2. And what is our final answer, guys?
Three plus this or minus the square root of 13.
Well, 3 over what is 3/2 times 1/2?
Three
What's
over
2?
4.
Good. I was like, what's 2 times 2? 3/4 plus square root of 13, also over what number?
4.
4. There's our final answer, guys. Just have to chug through all that fraction work, huh?
This is crazy.
That's everything we've been doing, though, right? Fractions are life. Okay.
You need a whole sheet of paper to do one problem.
That's math for you.
I never liked it.
You're not doing it right if you're not wasting sheets of paper, okay? Okay. Cool. All right. So I'll wait. I'll give you like 10 more seconds on that one before I move it. Yeah. Everybody good with that one? All right. Good, good, good. Okay. All right. I think we're good with that page. If we have time, we'll come back to those because we have similar problems down here. Oh my goodness. So I'll leave it up to you guys. 7, 8, 9, or 10.
Which question is going to be on the homework?
Oh, you'll have
Let's-
similar.
Or most similarly.
Let's do 9.
Let's do 9. Okay. We'll do number 9. Oh, and wait. Number 9 is just going to be like number 2. We're going to get imaginary number.
Let's do 10.
Let's do 10. That has more problems in it, right? Yeah. Number 9 is just like number 2. Okay. But again, we can come back to it when we have time. Okay. 10. So you have 3x squared minus 11x minus 4 equal to x squared minus 4x. And is this in the proper form?
No.
No, there needs to be 0 on the right side. So this means that the x squared and the 4x both need to move over to the left side. So we will subtract x squared, and then we will also add 4x. Okay, so this means we will get 2x squared minus 7x minus 4 equal to 0. So this now puts us in the proper format. Okay, and since we're in the proper format, what is the value of A, B, and C?
It's 2, -7, and -4.
Good. 2, -7, -4. And now let's go ahead and plug it into the quadratic formula. Let's see. Orange is good, right? Sure. All right. So here we go. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. There we go. We got it in the proper form. Now let's clean it up. So just keep working this way. -1 times -7, that becomes +7 plus or minus. And now in this square root, -7 squared becomes +49. And then -4 times 2 is -8. -8 times -4 becomes +32. And this is going to be all over 4. Okay, cool. Now let's keep working. So I'll move down here. X equals 7 plus or minus, and what is 49 plus 32?
81.
81? Yeah, 81. Good. All over 4. Oh, this is going to be a good one. What is the square root of 81?
9.
9. We finally get a nice one. Look at that. 7 plus 9 plus or minus 9 over 4. Okay, So since this is perfect, do not split it into two fractions. Let's just go ahead and do the plus and the minus. So we're going to do the plus route, and that's going to be 7 plus 9 over 4. And then we're going to do the minus route, 7 minus 9 over 4. All right. What is 7 plus 9?
16.
16 over 4. What's 16 over 4?
4.
4. Hey, look at that. There's one of our answers. All right. What is 7 minus 9?
2.
But it's
Negative.
-2 over 4. Well, what is -2 over 4? What does that reduce to?
1/2. -1/2.
There you go. 2 clean answers finally. Oh my goodness.
They all can't be like that.
No, unfortunately. I mean, we saw the last one, right? All right, cool. All right. Everybody good with this one?
So when you do the plus or minus, is that because of that plus or minus 7 plus or minus 9 over 4?
Exactly. So since they were such clean numbers, there were no square roots or anything crazy in there, we were able to split it off and say 7 plus and 7 minus.
Because they have a square root, that's what we need to do.
Yeah, if they don't, yeah. So if this was like 7 plus or minus square root of 9 over 4, we would have to keep breaking it down, and yeah. So.
Goodness.
Okay, let's hope all of them are clean like that, but I doubt it for your homework. All right.
Homework, we only should have 4 problems to do.
That's nice. All right, cool. So everybody's good with that.
Number 11.
Number 11, another fraction one. Oh my goodness. Let's see, what time is it? 7:40. And sure, let's chug that one out. And then that'll be the last quadratic formula one that we do. Okay. Zoom in. Let's get all the space we need for this one. It's going to be nasty. Okay. Cool. So this is not in the proper format, right? So this means that this guy needs to come over. So we're just going to add x over 5 to the left side. So if I do that, I'll have 2/5 x squared minus, actually, if I add that over, that'll be plus. So that's going to be plus 1/5 x minus 1/4 equal to 0. Okay. Awesome. So actually, let's think another way about this. Do we want to deal with the fractions? Or do you want to get rid of the fractions?
Get rid of them.
Get rid of them. Good. So look at your denominators. 5, 5, and 4. What is our common denominator between these?
20.
20. So this is what's beautiful about an equation. We can manipulate it. And what I'm going to do is multiply this whole thing by 20. All right. And it's going to get rid of our fractions so we can use the quadratic formula a lot nicer. Okay. So let's start with the first one. 20 times 2/5. 20 times 2/5. I'll write this out to the side. Well, 20 times 2/5 gives me 40 over 5. What is 40 over 5?
8.
8. So I get 8x squared. Ooh, that's nice, right? And then 20 times 1/5. I'll write this over here. 20 times 1/5. That gives me 20 over 5. What is 20 over 5? 4x minus, and then 20 times 1/4. 20 times 1/4 gives me 20/4. And what's 20/4?
5.
5. Woo. Does that look better than the one above it?
Mm-hmm.
For sure. Okay. We could have done that in the last one, probably. That crazy fraction one. Oh, well. We live and we learn. Okay. Perfect. And of course, 20 times that 0 is 0. Okay. So now we know. And what's the value of A?
8.
8.
8. What's the value of B?
4.
And C?
-5.
There we go. Let's quadratic formula this. Okay. So X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right. And now clean up. This becomes -4 plus or minus, and then inside the square root, 4 squared is 16. And then -4 times 8 is -32. And -2 times -35. Oh boy. What is that? What is 32 times 5?
160.
160. And that's all over 16. Okay, cool. And then let's see. This becomes -4 plus or minus the square root of, is that 176 over 16? Oh boy. 176. What makes up 176?
How low you want to go?
How big do we want to go?
16 times 11.
16 times 11. I love it. So good. So this can break down into square root of 16, square root of 11. And what is the square root of 16?
4.
4.
4. Can you break down the square root of 11?
Nope.
No. Okay. So this means that continuing here, we now have -4 plus or minus 4 square root of 11 all over 16. And now we're going to split it into 2 fractions so we can reduce, and you'll get -4 over 16 plus or minus 4 square root 11 over 16. And what does -4 over 16 reduce to?
Negative or positive 4.
-1 over 4 plus or minus, and is that the same situation over here? Four over 16. Ignore that square root for right now. 4 over 16. What does that reduce to?
1 over 4.
1 over 4. So this would leave you with square root 11 over 4. There we go. Oh, less brutal when you get rid of the fractions, right? How about that? There we go. Oh, man. Okay. Is that enough quadratic formula practice?
Think not.
No, but yes.
No, but yes. Okay, cool. I mean, label A, B, and C and just plug them in where you need to and simplify. It's probably the simplifying process that gets us. But don't worry, more practice because we still have a lot more notes to go. Okay.
Yay.
All right. So now the next part of these notes is about how many x-intercepts a quadratic function or a quadratic equation has. So what we were doing on the previous notes was we would find the way the graph opens and then find the vertex and plot it. And if it went through the x-axis, it had 2 x-intercepts. If it touched the x-axis, it had 1. If it didn't even cross the x-axis, it had none. Well, there is another way to find it without drawing. It is called using the discriminant. And the discriminant is the term that's inside the square root on the quadratic formula, as you see here. It is b squared minus 4ac. So if you use the discriminant, it can tell you how many intercepts you have. So using the discriminant, of course, you want to know the values of a, b, and c. And if the discriminant happens to be less than 0, this means you have no x-intercepts. Whoops, I put the dash on the wrong part. This means you have no x-intercepts, or what they're calling them here are roots. No x-intercepts, or you have no roots. And if you have no x-intercepts on a parabola, this means that, do you touch the x-axis?
No.
No. So you can say graph doesn't touch the x-axis. Okay. And then if the discriminant is equal to 0, this means you have 1 x-intercept, or you have 1 root. And if you have 1 x-intercept, this means we touch the x-axis. The graph will touch the x-axis. All right. And then the last one, if the discriminant is greater than 0, this means you'll have 2 x-intercepts. So you'll have 2 roots. And if you have 2 x-intercepts, this means you cross the x-axis.
Professor, you said it was if it was greater than 1?
If it's greater than 0.
Greater than 0, got it.
So the last one says if you're greater than 0, you have 2 x-intercepts. So less than 0, no x-intercepts. Equal to 0, 1 x-intercept. Greater than 0, 2 x-intercepts. Okay. Cool. And now the next example says use a discriminant to determine the number of x-intercepts you have without graphing. So everything's good here. Okay. So all you have to know is the values of a, b, and c. So look at number 13. What are my values of a, b, and c?
2, 4,
-4,
and 3.
-3. Good. And if you use a discriminant, you'll have b squared. So -4 squared minus 4 times a times c. So remember, we're using the discriminant here. So b squared minus 4ac. Okay. Clean it up. That gives me 16. And -4 times 2 is -8. -8 times -3 is +24. And 16 plus 24 gives me 40. Is 40 less than 0?
No.
Is 40 equal to 0?
No.
Is 40 greater than 0?
Yes.
Then how many x-intercepts do we have?
2.
2.
2 x-intercepts. That's it. That's all we have to do. All right. Easy, right? Without having to find the vertex or anything like that. Okay. Let's do it one more time and move on. All right, let's jump to, oh, we'll do 14. Why not? All right, full 14. What's the values of A, B, and C here?
4, 12, and 9.
Don't forget your negative. All right. So negative 12 squared, and then minus 4 times A times C. So this gives me positive 144 minus, and then 4 times 4 is 16. And what is 16 times 9?
$144.
And this gives us
0,
0. So how many x-intercepts?
0.
1.
1 x-intercept. Put
Yes,
the
right.
dash There you go. 1 x-intercept. So I'm assuming the next one's less than 0, so no x-intercepts. But again, we're short on time and we have a lot to cover. So let's keep moving. All right. Everybody good with those?
Seems easier than the other ones you were doing.
Oh, for sure. That was just a piece of the quadratic formula. Okay. All right. Next. All right. Says spot the error and correct it. Okay. So let's look at this real fast. Okay. Spot the error. So here they have 2 plus or minus the square root of 121. Can you break down the square root of 121?
It's 11.
It's 11. So what's wrong with this student's answer?
He left the square root.
He left the square root on. So square root of 121 is 11, not the square root of 11. That's it. That was simple. All right. And then 17. Yeah, 4x squared equal to 12x. And they said that A is 1, B is 0, and C is negative 12. What's wrong with this one?
B,
B. What should the value of B be?
negative 12.
Good, because if you rearrange this, you'd have 4x squared minus 12x equal to 0. And A should be, actually, A is wrong too, right? What should the value of A be?
4.
4. And B should be negative 12. And C should be 0. Okay. Yay, fun. All right. Cool. All right. And keep it moving. Next is sketch the graph. So doing stuff we know already, and now actually finding x-intercepts by using the quadratic formula. Okay, so look at this function. Negative 2x squared plus 4x plus 1. Will this open up or down?
Down.
This is going to open down because the leading term is negative, right?
Right.
So we open down. Okay, now we need to find the axis of symmetry. But in order to do that, we need to look for the vertex, right? So let's just go ahead and get this started. Let's list everything we know. What are the values of A, B, and C here?
Negative 2. And 4.
And 1.
And 1.
We know we only need A and B for the vertex, but since we're going to find x-intercepts, let's go ahead and label that value of C. Okay. Oops. So there we go. Vertex we'll find first. So H equals negative B over 2A. And we'll have negative 4 over 2 times negative 2 which gives me -4 over -4, which gives me 1. And then k is going to be f of 1, which is going to be -2 times 1 squared plus 4 times 1 plus 1. So that gives me -2 plus 4 plus 1. And -2 plus 4 is 2, and 2 plus 1 is 3. So there's our vertex. It's going to be at 1, 3. So 1, 3. And remember, if you have the h value for your vertex, you have the axis of symmetry. So it's going to be x equals 1. Okay. And then for your y-intercept, remember how to find the y-intercept. You let x equal
0.
0. So you'll have f of 0. And if x is 0, that's 0, that's 0. And what are you left with?
1.
1. Oh, so nice. So our y-intercept is going to be at 0, 1. Okay, well, now we know how to find x-intercepts, so we're going to use the quadratic formula. Yee-haw. So here we go, guys. X-intercepts, we let y equal 0, or in this case, f of x equal to 0. And let's quadratic formula this. We already have a, b, and c above. So we're going to have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. Now this will give me -4 plus or minus the square root, and that is going to be 16. And then that's -4 times -2. So that's 16 plus 8 and over -4. Okay. And now 16 plus 8, that gives me -4 plus or minus the square root of 24 over -4. All right. Give me two numbers that make up 24.
6 and 4.
Let's go 6 and 4. Good. We know square root of 4 is 2. Can we break 6 down anymore?
3 and 2.
You can, but can we take the square root of those two numbers?
No.
No. So we're going to leave it as the square root of 6. Okay. So now we have -4 plus or minus 2 square root 6 over -4. And this is going to become, we'll split this up. You will have -4 over -4 plus or minus 2 square root 6 over -4. And what is -4 over -4?
1.
1. And this is going to be cool and mind-blowing at the same time. Guess what this negative is going to do to these signs here? It's going to flip them. It's going to make them minus plus. Oh, crazy, right? So
There are difference?
that's pretty fun. There is no difference, but we have to account for that negative.
Gotcha.
So it's fun. It's a fun thing. You get to flip those. You never see those flipped. So it's pretty cool. Okay. So now you just have to reduce 2 over 4. What is 2 over 4 reduced to? I think somebody said a half. I heard it muffled. And there you go. These are your x-intercepts. Ugly, ugly, ugly. And you can even put them as a coordinate. You can say 1 minus plus square root 6 over 2 and 0. All right. We're definitely not graphing those. Just ugly, ugly decimal number. Okay. So we found our x-intercepts. I'll put those here. 1 minus plus square root 6 over 2 and 0. And now let's just graph the rest of it. We're just going to use the vertex and the y-intercept. So my vertex is at 1, 3. So here's 1, there's 3. My vertex is at 1, 3. My y-intercept is at 0, 1. So right here is my y-intercept. And then we have our lovely axis of symmetry that cuts through this point. So how can I find one more point to help us graph this? What could I do here? Can I reflect that point over?
Yes.
Yes. Since it's only one space away, it's going to be one space away that way. And just connect. And then right here are those nasty decimals x-intercepts. Okay. What is the domain of all of these functions?
Negative infinity.
Negative infinity to infinity. Since this opens down, where do I start my range at?
3.
Opens down. Where are these tails headed to?
Oh, wait, negative infinity.
And then we come up and we stop at what number?
3.
3. There you go. Cool. All right. So that we were used to that. The only new thing was actually finding the x-intercepts by using the quadratic formula. Okay. Everybody good with this one? Okay. All right. Now the fun stuff. Okay. 19. After t seconds, a ball is tossed in the air. The ball reaches a height of h feet given by the function h of t equals 5 plus 144t minus 16t squared. So t is given as time, as seconds. So in A, it says, what is the height of the ball at 3 seconds? So this means all we have to do is plug 3 in for what variable?
T.
T. Good. Let's see. Okay, nope, that's too small. Boom, boom, boom. That's perfect. Okay. And I don't need that. 1, 2 up. One moment. I just need the scientific calculator, right? Okay, cool. So for this one, we're just going to plug 3 in. So you'll have h of 3 equal to 5 plus 144 times 3 minus 16 times 3 squared. So let's see what we get. 5 plus 144 times 3 minus 16 times 3 squared. And we get that at 3 seconds, the ball will reach 293 feet.
Now, why wouldn't you switch that around?
Like put the highest power first?
Yeah.
You can if you want. It doesn't have to though. So if you want to rewrite it as negative 16t squared plus 144t plus 5, that's perfectly fine. Okay. So now it says, what is the maximum height the ball will reach? What are we looking for here?
5 feet.
Vertex.
Vertex. We're looking for the vertex. So in this case, we want to know what A and B are. So what's the value of A on our function above?
-16.
And B is 144, right? So H is negative B over 2A, and you get negative 144 over 2 times negative 16. So negative 144 over negative 32. And 144 over 32 is 4.5. So we now know to reach the maximum height is going to take 4.5 seconds, but we want the maximum height. So we take 4.5 and plug it into the equation above. So to find K, you have H of 4.5, and I'm just going to use the calculator over here. So now since I wrote it the other way, I'll type it in that way. Negative 16 times 4.5 squared plus 144 times 4.5 plus 5. And the maximum height is going to be 329 feet. Okay. Now, next, find the number of seconds the ball is in the air when it reaches a height of 229 feet. So now they're giving us height and they want us to find time. So that's what we're doing on this one. We have to find time. Okay. So this is going to be a little bit of work here. So for C, they say the height is 229 feet. What is the value of T? So what we're going to do is take our equation and set it equal to 229. So we're going to take negative 16t squared plus 144t plus 5 and set it equal to 229. And now we're going to solve for t. Okay. So, of course, this is going to use the quadratic formula. So you have to subtract this over to the left. So if you do that, you'll have negative 16t squared plus 144t minus, and 5 minus 229 should be negative 224 equal to 0. Okay, so now in order to solve for time, we have to use a quadratic formula. So the value of A here, A is negative 16, B is 144, and C is negative 224. And now, since it's in terms of T, you'll have T equals, and it's going to be negative B plus or minus the square root of B squared minus 4 times A times C. All over 2 times A. Okay. Clean up. You have negative 144 plus or minus. And now inside, I'm actually going to calculate that over here because I don't want to write out what 144 squared is. So I'm just going to say square root 144 squared minus 4 times negative 16 times negative 224. Oh my goodness, that came out real nice. Look at that. You get 80 over negative 32. So the square root of all of that becomes 80. That's worked out very nice. Okay. And now since we have clean numbers, we'll do the plus route and we'll do the minus route. So plus will be negative 144 plus 80 over negative 32. Minus will be negative 144 minus 80 over negative 32. So let's see what we get. Negative 144 plus 80 over negative 32 gives me 2 seconds. And then next, negative 144 minus 80 over negative 32 gives me 7 seconds. There we go. Quadratic formula strikes again, guys. Okay. Everybody go with that one. We're gonna run out of time, but let's just stick through it. If you gotta leave, that's fine, but you can watch the recording for the last of it. Okay. All right. So that was C. So the ball will be 229 feet at 2 seconds and at 7 seconds. Okay. And then for D, how many seconds will it take for the ball to hit the ground? Well, if you hit the ground, what is the height? 0. So again, just like the one above, they're giving us height. So we have to find time again. So they're saying the height is 0 feet. And again, we have to look for time. So guess what we have to use again, guys?
Quadratic formula.
Quadratic formula. And it's going to be on the original function above. So if height is 0, then again, it's going to be negative 16t squared plus 144t plus 5 equal to 0 this time. And now, using the quadratic formula, we have A is negative 16, B is 144, and C is 5. So quadratic formula, T equals, again, negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right. And again, negative 144 plus or minus, and let's figure all this square root stuff out. Square root of 144 squared minus 4 times negative 16 times 5. And this time we get a decimal number. All right. So we get, I'm just going to do it to 2 decimal places. 145.11 over negative 32. Okay. And then once again, plus route, minus route. So negative 144 plus 145.11 over negative 32. And then minus negative 144 minus 145.11 over negative 32. All right, let's see what we get. Desmos a go-go, right? Negative 144 plus 145.11 over negative 32. Here, you get negative 0.03 seconds. What's wrong with this answer? Can time be negative?
No.
No. So we can't use this answer. But now let's check the other one. Negative 144. Oops. Forgot that. I messed that whole thing up. Division first. There we go. Negative 144 minus 145.11 over negative 32. In this one, we get 9.03 seconds. So the ball will hit the ground in 9.03 seconds. Okay. And the other one, the reason we have a negative time is because if you look back at our function, we're actually throwing it from 5 feet high. So that's what that 5 is for. So remember, if you plug in 0 for time, that 0, and whoever's throwing the ball is 5 feet tall. So they're throwing it from a height of 5 feet. So that's why you have that negative time there. Okay. Okay, and then last, right? A reasonable domain and range for this situation. Okay, so domain deals with time here. So domain deals with time. So if we haven't thrown the ball, how much time has gone by? 0 seconds. But now we know that when we throw the ball, when's it going to land?
9.03 seconds.
9.03. Good. All right. Now, what is a good range for this? Well, does the ball hit the ground?
Yeah.
So if you hit the ground, how many feet are you at?
0.
0. What is the highest we can throw the ball in the air?
5 feet.
Well, that's where we start. What is the highest? What's the maximum height this ball goes?
329 feet.
329 feet. That was a vertex, right? So we throw the ball and it goes 329 feet and it also hits the ground. So the range is at 0 to 329. Okay. So that's not bad. Again, more quadratic formula, right? So that was range and this was height. Everybody good on this one? Okay, let's finish this last one. I understand if you have to go, but it's the last one. Why not? Oh, there's my computer's like, no, you're not finishing this. Let me glitch. Okay, 20. A ball is thrown upward from a height of 15 meters with initial velocity upward of 5 meters per second. use the function h of t equals negative 4.9 t squared plus 5t plus 15, where h is in meters and t is in seconds, to find how long it will take for the ball to hit the ground and graph the function. Okay, so all we want to know right now is how long, how many seconds will it take to hit the ground? So they're giving us height. If the ball hits the ground, what's the height?
0.
0. So we need to find time. So they said height is 0. What is time? So again, just like we did on D above, we're going to take all of this, set it equal to 0, and use what?
Quadratic form.
Quadratic formula. Our best friend today. We use the quadratic formula. We take all of that, set it equal to 0. We know A is negative 4.9. We know B is 5, and we know C is 15. There we go. And now, since it's in terms of T equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Okay. Everything's plugged in. Let's simplify. T equals negative 5 plus or minus, and let's figure all this square root stuff out. Square root of 5 squared minus 4 times negative 4.9 times 15, and to 2 decimal places, 17.86 over 2 times negative 4.9. I think that's 9.8. So negative 9.8. Okay, now the two routes. You have the plus route and the minus route. Negative 5 plus 17.86 over negative 9.8. And negative 5 minus 17.86 over negative 9.8. Let's see what we got. Negative 5 plus 17.86. Oops. Over negative 9.8. You get negative 1.31, but can we use that answer? Nope. Can't have negative time. And then for the next one, negative 5 minus 17.86 over negative 9.8. And we get 2.33 seconds. Okay, cool. Now, last part is to just graph this function. So if time is 0, what height do we start at? If time is 0, what do we start at?
15.
15. We start at 15 meters. So let me zoom in a bit. We're almost home, guys. So let's just do this as like 5, 10, 15. So this is where the ball starts. All right. And then here is 0. And how long does it take for the ball to hit the ground? How many seconds did we find out?
2.33.
2.3. So let's make this 1, 2, 3. So we know the ball will hit the ground in 2.33 seconds. Oh, I skipped too many on that one. Oops. This will be 3. Okay. So we know the ball will hit right around here. So our graph will look just like that. And that's it. Now we're done.
I don't like this.
Oh, it's fine. Again, it's the quadratic formula. The applications, of course, a little more extra work. Just know what they're asking for. But other than that, for using the quadratic formula, if you know A, B, and C, plug them in and simplify. That's it. Okay. Now we're done.
My head hurts.